Okay, hi, it's 3:29 and we're going to go over the homework. So, first one I'm going to do is page 23. Okay, this one are the ones that I wrote that are really, well, not really, but a little bit more challenging. So, we have a question. Shelley compared the number of oak trees to the number of maple trees as part of the study. Okay, and she counted 9 maple trees to every 5 oak trees. So, let's write that down because we're going to need that information. So, here we go. And we have right over here 9 maple and 2 5 oak. That was before, okay, right, 5 oak. Okay, and before the bug problem. So, and after the bug problem, okay, the new ratio of maple trees to numbers was 3 to 1. So, I'm going to write it a little bit lower. 3 maple trees to every 11 oak trees. That's after the bug problem. So this is pre and this is post. Okay, post bug problem. So what I'm going to do is, what the other piece of information is that we have is that there are 132 trees now. Okay, so let's do a, I think it's easier if we do, actually, do we have a choice? Yeah, we have a lot of choices. Okay, so let's do it this way. Let's do it with a proportion. 3 maple, 11 oak. Okay, and we know that we have 132 oak. So, oak. I don't know, that's ugly. So, what times 11 gives you 32? What times 11 gives you 132? So, there's a relationship there, and it's times 12. So, times 12, and so the top will be times 12, which gives you 36 maple. So, we now know what the total is, okay, because it says there's the same amount of trees. So, post, after the bug problem, there are 36 maple trees, plus 132 oak, giving you a total of 168 trees. That's the total number of trees. We can now go back to the pre-bug time. Let me just draw a very ugly line right here. Okay, so I know that in my early days there were 168 trees, and the ratio was 9 to 5. Okay, so I'm going to use the information I found with the post and my pre. Now, the easiest way to do this, let's see, I would do a tape diagram. So let's see if I can do a tape diagram. Here we go. And I would do a little thing here like that. Okay. And I would go 1, 2, 3, 4, 5, 6, 7, 8, 9. That would represent my 9 maple. And I'm going to do my 5 oak. And it's going to be all the way up here. 1, 2, 3, 4, 5. Okay, now what I do know, and let me just write OA here so that you don't confuse that with a 0, is that there was a total of 168 trees. So let me see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 spots here. There are 14, and I have to fit 168 in those 14 spots, which is going to make what? It's going to make that every box here 12. 12, 12, 12, okay, and 12, 12, 12. So, pre-bug, in my pre-bug days, okay, when actually, yeah, there were how many oak trees? 12 times 5 gives me 60, and 12 times 9 gives me 108, okay, and that's my new numbers, okay, my numbers, okay. So, there were 108 maple trees and then 60 oak trees, and then they had a bug problem. A lot of them died, so they planted a lot of trees. Your new ratio came out to be 3 maple trees for 11 oak trees, okay, giving you 36 maple trees to 132 oak trees, and that total 168 is the same as the uh, ratio above. Okay, so two scenarios. So, second problem, the school band's comprised of middle school students and high school students, but it always has the same maximum capacity. Okay, last year the ratio of number of middle school students to number of high school students was 1 to 8. So, let's write this down. Middle, and I'm going to write to high, and 1 to 8. So, one middle school student to every high school students. This year, the ratio of number of middle schools and number of high school students changed to 2 to 7. So, 2 to 7. Okay, there are 18 middle school students in this band this year. How many fewer high school students? How many fewer high school students are there in the band this year compared to last year? Well, okay, so and this year there are 18 middle school students. So let's figure out. This is last year, and this is this year. Okay, this year. All right. So this year the ratio is 2 to 7. 2 middle school students for every 7 high school students. But there's another piece of information that we know. So let me write that as a fraction, 2 over 7. And I'm going to go 2m to every 7 high school students equals. And here I can write 18 middle school students. And if I have 18 middle school students, the relationship here is 2 times 9. So I'm going to do 7 times 9 at the bottom, which is going to give me 63 high school. So this year, the total number of students is those two numbers added up together, 18 plus 63, which is going to give me, there's a total of 81 students this year. And it also tells me that the number of students don't change. So this year there's 81 students. Last year there were also 81 students. Alright, that piece of information is very important. So let's go back to last year and we can create a tape diagram. This is the middle school, this is the high school. Tape diagram, there would be 1 box here for the middle school and 8 boxes for the high school. 1, 2, 3, 4, 5, 6, 7, 8. There. How do I fit 81 into these 9 boxes? It would be 9 in each box. Okay? Remember, tape diagram, once you find one number, it would all be the same. So 81 fits into these 9 boxes by putting 9 in each. So last year there were 9 middle school students. Okay, and let me write 9 over here, and 8 times 9 is 72, and 72 high school students. Whereas this year, I have 18 middle school students and 63 high school students. So the answer to the second question is, how many fewer high school students are in this band this year? Well, this year they have 63, last year they have 72, so it's a difference of 9. Okay? So basically you have to find, you have to do a little calculation with the ratio for this year, which you then found the total number of students, and use that information to go back to last year and figure out the other information. Okay, so that's page 23. Okay, so let's go to page 25. 24, 25, and one more. Okay. On page 25, we have 4 questions. Sammy and Caden went fishing using live shrimp as bait. Sammy brought 8 more shrimp than Caden bought. When they combined their shrimp together, they had 32 shrimp altogether. How many shrimp did they each bring? Okay, so you know there's a total of 32. Okay, there are a total of 32, and then we have Sammy and Caden. So whatever they each brought, I know the total is 32. Now I have to figure out 2 numbers. Okay, where the difference is 8. So let's say, for example, I know if Sam brought 10, it means Caden brought 2. Why? Because the difference is 8. He brought 8 more. But obviously 10 and 2 are not the numbers because it has to add up to 32. So let's think of 2 numbers here that I can think of that matches that. So let's do, I don't know, 22 and 10. So let's say Sammy brought 22 and Caden bought 10. Will that work? Well, 22 minus 10 is 12. That's not the difference. The difference has to be 8. Sammy brought 8 more. Okay, so let's try another one. I don't have to erase. Maybe I'll just keep this. Okay, you're gonna have to play with the numbers here. 24 and 12. No. No, 24 is not going to work because 24 and 8, that's 32, but the difference is too much. So let's think of other numbers. Alright, so let's think of another two numbers. Let's try 20. 20 and 12. So Sammy brought 12 and Caden brought 12. No, Sammy brought 20 and Caden. What's the difference between 20 and 12? The difference between 20 and 12 is, if you subtract 20 minus 12 equals 8. Did Sammy bring 8 more than Caden? Yes, it is. So we have our two numbers here that fit the requirements. Okay, so we can say that Sammy brought 20 and Caden brought 12, and that's the answer to letter A. Okay, what's the ratio? The ratio is going to be 20 to 12. Anytime, every time Sammy brings 20, Caden brings 12. So there's your ratio. You can simplify it if you want. Okay, express the number of shrimp Sammy brought as a fraction of the number of shrimp Caden bought. Okay, express the number of shrimp Sammy brought as a fraction. Okay, so Sammy brought. Okay, let's do D and I'll come back to C. What's the ratio of the number of shrimp Sammy brought? Sammy brought 20 shrimp to the total number, which is 32. Okay, so that's D. Now C, express the number of shrimp Sammy brought as a fraction of the number of shrimp Caden brought. So let me just think about that for a second. Alright, not too sure about C here. I'm not sure what they're asking, so let me think about it and I'll tell you guys tomorrow in class. I'm going to skip that one, so remind me tomorrow. So, next we got 32. Let me go to page 32 and clear this section over here. Okay, which is not working. There we go. And 1 second. Alright, next question is on page 32. It says, to make paper mache, ooh, I used to love that. The art teacher mixes water and flour. For every 2 cups of water, she needs to mix in 3 cups of flour to make the paste. Okay, find the equivalent ratios for the relationship between 2 cups of water to 3 cups of flour. Alright, using a table, it's no different than you've been doing, only it's set up differently. Okay, so let me do it this way first. 2 cups, and we're going to call this water. And 2 cups of flour, let's call it F. Sorry, 3 cups of flour. Make that 3. You want to make equivalent ratios. You can do it as a table, or you know how to do it. So another equivalent ratio to this would be, let's say, times 2 top and bottom, 4 over 6. Another equivalent ratio, let's say, top and bottom times 10 would be 20 over 30. Okay. And you can go on and on and on. The only thing nice about a table is that it's nicely, in a table. So, see, so we have cups of flour here, cups of water, I'm sorry, water on this right rider, and cups of flour. One day I'll learn how to write with this thing. Okay. And we're going to create a table, not as pretty as the one on your sheet. But, so, the first one that we can write is 2 to 3. Okay, I guess visually might be more appealing to. Okay, and this is going to come in handy when we're graphing, so yeah, there's a point to this. 2 cups of water, 3 cups of flour. We can make 5 different ones. Okay, so we can go 4 and 6. Let's just do it in order. Times 3 would be 6 and 9. Times 4 would be 8 and 12, and 10 times 5 would be 10 and 15. There. 2 to 3, 4 to 6, 6 to 9, 8 to 12, 10 to 15. They're all equivalent to our first given ratio. Okay? That's simple enough. So let's see. And then that's it for that page. And page 33. Okay, 33. No different. Ooh, the ratio is written sideways. Don't let that confuse you. Javier has a new job designing websites. He's paid at the rate of $700 for every 3 pages. Are you serious? $700? Huh. Create a ratio table that shows the amount of money Javier has earned in ratio to the number of pages he's built. My goodness. Alright, so let's do this sideways. Go, here's the pages, and here's the money. Okay, and we're going to go sideways. No different. Okay, only mine is definitely uglier and more crooked, but nevertheless. Look at fish. Well, anyways, so let's write our initial ratio. The one ratio we know is that if he does 3 pages, he gets $700. Okay. I wouldn't do 4 or not more than 5, because then it gets into decimal. So let's just do a nice one. So let's double that. What happens if he does 6? He can get 1,400. What happens if he does 9 pages? He gets, which is times 3 over here, so times 3 is 2,100. 12 would be times 4, and then times 4 at the bottom, 2,800. And you can go on and on and on and on. But the thing that they said was, Javier's saving to purchase a car that costs 4,300. How many web pages will he need to build? Well, let's leave 4,300 for this corner right here. Okay, there's a reason why I'm saying this, because obviously I can tell that 7 doesn't go to 4,300 evenly. Okay, so I should have. Well, let me try to split this half. All right. Let's do times 6. Times 6, 700, or let's say times 6 would be 4,200. 4,200 times 6 on the top would be 18. So if he did 18 pages of a website, he would make $4,200. Is that enough? No, it's not. So he needs to do a little bit more. And the next one he's going to do is 21 pages. How do you get 21 pages? This would be 3 times 7. At the bottom be times 7. So it would give you 4,900. Okay, 4,900. So the least amount of pages that he needs to do is 21 pages, because at 18 it's not going to work. And does he charge for every 3? I guess he charges by 3. So if somebody said I need 19, he'd probably say no, I can't do 19 because it has to be multiples of 3. So from 18, the next set would be 21 pages. So in order for him to buy that used card, he would need to do a minimum of 21 pages, where he would make $4,900, which would be very sufficient to buy the car that he chooses. Okay, that was 33, very easy. And we're going to 34. Okay. You know what? Let me just check a couple of things here. Alright, so okay, 34. Spraying plants with cornmeal juice is a natural way to prevent fungal growth on the plants. It is made by soaking cornmeal in water, using 2 cups of cornmeal for every 9 gallons of water. Alright, so there's our ratio right there. So we get, it says that we need 2 cups. Okay, 2 cups of cornmeal, and I just write corn, for every 9 gallons of water. 9 gallons of water. So I did not know that you could use that. Okay, to prevent fungus growth. Huh, interesting. So, how many cups of cornmeal should be added to make 45 gallons of water? Well, here's your table. Okay, and you notice that there's a lot of boxes. Okay. So our first question says, if you have 48 gallons of water, 45, I'm sorry, is that 45? Yes. Sorry, it's very tiny. 45 gallons of water. How many cups of cornmeal do you need to add it to create that natural pesticide, I guess you want to call it? Well, the relationship 9 to 45 is obviously times 5. So you're going to apply the same thing over here. So 2 times 5 is 10. So if you had 45 gallons of water, you would need 10 cups of cornmeal. Okay, nice and easy. B, Paul only has 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal as he can? Well, so let's put 8 over here. What will happen? Well, if it's 8 cups of cornmeal does he have, from 2 to 8 is times 4. So from 9 will be times 4, which gives you 36 gallons of water. Okay, and what can you say about the values of the ratios in these tables? Well, 2 to 9 is proportional to 10 to 45, and 2 to 9 is proportional to 8 to 36. Okay, I mean, I'll just write it here at the bottom. 2 to 9 is proportional to 10 to 45. Is that true? You can see that it is, because the growth was times 5 on top, times 5 at the bottom. And 2 to 9 is also proportional to 8 to 36. No, it's not. I'm doing something wrong. It's supposed to be 2 times 4 and 9 times 4 is 36. I did that correctly. No. There's something wrong. 1 second. Nothing wrong. Something wrong with me, because it's not 2 over 10. It's 2 over 9. Okay, so... Alright, and 2 over 9 is proportional to 8 over 36. 2 times 4 is 8, and 9 times 4 is 36. Okay? And we have page 34, which is that one. So let's go to 36, which is this way. 1, 2. Ooh! A ratio table is a table of pair of numbers that form equivalent fractions. So here you had 3 tables. Okay, and you just had to fill in the blanks. Okay, so let's see if we can find a relationship here. Alright, so in table 1, I wish I could write on that. Table 1, you see a bunch of numbers, and I'm hoping you can see a pattern. 66 to 55 to 44 to 33. So let me fill in the... No, so let's do one at a time. So number 1, blank, blank, and then you had 22, blank, 44, 55, 66, and you had 24 on this side. That's 16 on this side. And you have a 12 on an empty spot. I'll make it like this, make it like this, make it like this, and like that. And you had 2 more empty spots on the top. Okay. So whatever's happening here, 11 is doubling. Okay, I think you can see that. So let me change colors, because that will tell you what I'm filling. So with red will be the empty spot. So from here, 11 to 22 is times 2. 11 to this spot should be 33, 54, 55, 56. Now let's figure out the other side. Okay, so something times 3 gives you 12. Okay, something times 4 gives you 16. So obviously the number here should be 4. Let's see if it works. Well, to go from here to here has to be times 3. Is that what happened on the other side? 11 to 33? Was it times 3? Yes, it was. So let's go to the other one more down. 11 to 44 times 4. 4 to 16 is times 4. 11 to 55 is times 5. And 4 should be times 5 as well, which should give you 20. 11 to 22 is just double. So 4 to this empty spot, double, which should be 8. Okay? Simple enough. Next one, we have another one that's empty. And like this, and this time I'll change colors to red as the initial position. And let's see, 1, 30, 25, 35, 15, 21, 14. Ooh, this looks simple. You know, here on this side, it looks like it's multiple of 7s. On the other side, it's multiple of 5s. Let's see if that works. So with black, I'm going to put a 7. 7 times 4 times 2 is 14. Times 3 is 21, so it follows a pattern. Times 4 is 28, times 5 is 35, and times 6 is 42. So ask yourself, Let's fill in this spot right here. Okay. Something, no, let's fill in this spot right here. Okay. Let's use 15 to figure out our initial number. So something times, and let's see, from 7 to 21 is times 3. So something multiplied times 3 gave you 15. What multiplied by 3 gives us 15? Has to be 5. Alright? To get to this space right here is times 2, so 10. To get to this space is times 4, which is 20. And we have finished our table. And last one. Is this it today? It looks really easy. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, so let's see what we have here. 18, 102, 85, 15, 12, 51, 34. Oh. Okay, if you look at these numbers here on this side, I am going to say, okay, let's see how I would do this. You have to recognize what the multiples are, what possibilities here. Here on this side, 12, 15, 18, they're all multiples of 3. Here on this side, 34, 51, 85, 102, well, they all look like multiples of 17. Let's see if that works. So let me change color. So let's pretend or assume that's 17. Does it work? 17 times 2, 34. 17 times 3, 51. Let's skip that one. 17 times 5, is it 85? Yes, it is. And 17 times 6 is 102, so that works. So here would be 17 times 5, not 5, times 4. Okay, 17 times 4 would be 68. And that's how I got my number here. So, I know, let's go back here. Okay, from 17 to go to 68 is times 4, so it should be the same factor over here. So something times 4 gives you 12, and that something obviously is 3. And there, it's your multiples of 3. So to go here, you double. 3 times 2 is 6. You triple. 3 times 3 is 9. And there's your ratio, 3 to 17, which is equivalent to 6 to 34, which is equivalent to 9 to 51, which is equivalent to 12 to 68, and blah, blah, blah. Okay? So that's it, and I don't, well, am I right? No, there's one more page. Okay, these were very simple. I choose the easy questions. I chose this one. Alright, the following tables were made incorrectly. Oh, yes. Find the mistake that was made, create the correct ratio table, and state the ratio that was used to make the correct table. Okay, so here we go. So let's see. I'm looking at it. You can follow with your own. 3 to 24, 3 to 5. All right, 103 times what the heck? Wait a second. All right, let me take a look at this. See if I can find the mistake. All right, so I think I found a mistake. So let's take a look at this. Look here on this side. It says that in 3 hours, you work 3 hours, you get $24. You work 5 hours, you get $40. You work 7 hours, you get $52, and then you work 9 hours, you get paid $72. Hoping you know that there's a relationship. If you work 3 hours, and I'll write it here on this side, you work 3 hours and you get $24. It means it was times 8. If you work 5 hours and you get $40, it means it was times 8. So there, I just found the relationship here, okay, between hours and the amount that you get paid. So the mistake is in the 7, because if you work 7 hours times 8, you should get $56, but instead they wrote 52. And then finally, 9 hours that you work, you get paid $8, and you get $72, which is the correct one. So the mistake in letter A was this one. And that's what they wanted you to write correctly on the right side. Okay? B, let's see if we can find the relationship here. Blue and yellow. So 1 blue, you get 5 yellow. 4 blue, you get 8 yellow. Huh. 7 blue, you get 13 yellow. What in the world? 10, you get 16. So what is wrong here? 1 to 5, 4 to 8. What if you get 4, you get 8, you get 7, you get 13, you get 10, no. 10, you get 16. 1, you get 5. 4, you get, no, that's not going to work. 7, you get 13. And 10, you should get 20. Subjective times 1, you should get 20, which should be double. 7 to get 30. No, that doesn't work. 4 to 8. No, well, the ratio is 1 to 5. I'm assuming, let's say, assume the first one is correct. It would be 1 to 5. If you have 1 blue, you have 5 yellow. If you have 4 blue, you should have 20 yellow. If you have 7 blue, you should have 35 yellow. But then the numbers are too far apart. So 1 can't be the one that we want to work with. Well, 4 to 8, it just means double. So if you have 4 blue, you double, and you get 8 yellow. So every time I have 4 blue, I don't know, pencils, I have 8 yellow pencils. If I have 7 blue pencils, I should have 14 yellow pencils. If I have 10 blue pencils, I should have 20 yellow pencils. Is that the one? 7 to 13 and 10 to 16. Gee, so no. Oh, let me write it on this side. 1, 2, 3, 4. If I assume that the one I want to work with, okay, well, assume that the one I want to work with is this one, and I'll use red. 4 to 8. Okay, 4 blue, 8 yellow. Then everything else is very easy. So if I have 1 blue, I should have 2 yellow. If I have 7 blue, I should have 14 yellow. And if I have 10 blue, I should have 20 yellow. Very, very easy. Okay, and you know that the ratio works because 2 to 8 is 4, 1 to 4 is 4, 2 to 14 is times 7, and 1 to 7 is times 7, and 2 to 20 is times 10, and 1 to 10 is times 10. So that would have worked nicely. But is that the one? That seems just too easy to give to you guys to do. So let's assume something else, just for example's sake. Let's assume 7. Well, you know what? If you assume 1 and 5, okay, 1 blue, 1 yellow, 5 yellow, you're going to assume that for 4, every time you have 1 blue, you have 5 yellow. For 4, you would have 20. For 7, you would have 35. And if you had 10 blue, you would have 50 yellow. So there's that choice too. So I guess here you can make choices between assuming that 1 to 5 ratio is the correct one, or the 4 to 8 ratio is the correct one. The 7 to 13 doesn't really make sense because that's going to give you a decimal number. Okay, and then 10 to 16, it also doesn't make sense, to give you that one. Unless you want to multiply everything by 1.6, which I don't think that's what you want. So you can choose, I would assume, either the 1 to 5 ratio or the 4 to 8 ratio, and use that to finish the rest of the page. Okay, I know it's late, it's 4:16. I know I wrote 4 o'clock. My apologies. And if you have any questions, email me. Okay, if I didn't cover something too fast, let me know. Okay, so that's your homework for tonight, and we'll cover the handout in class for a few minutes. Okay. Okay. Oh, let's make it interesting. So tomorrow, when I check to see if you did this, I want you to make sure that you have this word on top of your paper, loose leaf. Okay? Okay? Marilla. What does it mean? You'll find out tomorrow. Okay? But that's your secret word for tomorrow. All right? So, that's that. See you tomorrow.